Welcome to the workshop. Today we want to take a look at section 2.2, Equivalence Relations. So in our last section, we looked at sets and some set operations. And here we want to consider relations, which are, of course, related to some of our sets and set operations. So if we want to look at a relation from a set A to a set B, this is simply a subset of the cross product of A and B. So A cross B. Excellent. And if we were to have B be the same set as A, then we would have a binary relation from A to A, or simply a binary relation on A. And that is a subset of A cross A. Excellent. So if we have a relation, a subset of a cross product, that relation is denoted by typically a capital R, though other letters can be used to refer to a relation as well, but typically denoted by R. And for this section, definitely. So what we do is we say if x comma y, right, if this ordered pair is in R, that is, if it's in the relation, then we say that x is related to y. Now, we want to recognize here that an ordered pair, right, x comma y, is not the same as the ordered pair y comma x. So whenever we talk about x comma y, or x is related to y, we don't necessarily know that y comma x is in the relation, or that y is related to x. But we do know, again, because it's ordered, all we know is that x is related to y, x comma y is in the relation. Okay, so these two are not the same thing. Okay, ordered pairs, order matters. All right. So in the last section, we took a look at an example of finding a cross product where set S was 1, 2, 3 and set T was A, B, C. So we already found what all possibilities of combinations of S and T are, or elements from S and elements from T. So let's give an example of relation R from S to T, which just means that our first ordered pair, or the first element in our ordered pair comes from S, and the second comes from T. So there are a lot of options. We could make it pretty simple. We could make it somewhat complex. So if we have, let's see, we could choose 1 and A. We could choose 2 and C. We could choose 3 and A as well. But it could be any subset of the cross product. So I can go back and start repeating things, much like I repeated the A. I could repeat the 2, for example, 2 comma B. It doesn't matter, right? These elements are in the cross product, so we know that that's fine. So that's one example. If we wanted to, we could give another example. So let's call that one R1. Let's say R2, some other relation. So let's go. Let's go to A, 3A, 2B, and 3B. Sure, that looks good. Doesn't matter. Right? It's just a collection of, right, well, and even 4 elements. It doesn't need to be that number of elements specifically. So we could have more there. 1A. There we go. Any number. All right. Let's take a look at another example. So again, a relation is just a pairing, an ordered pairing of an element from one set and an element from another set. Set A, set B, you get your ordered pair. All right. So let's take a look at another example. So let's let P be the set of students at CUAA, right? Maybe think of it as the population of students, and let S be the set of sports teams at CUAA. And we can define a relation where X is related to Y if and only if X is on the Y team. So let's list several elements of R. All right, so we're not going to list them all, right? There's a lot of students and a lot of teams. But I took a look at our excused absences for this week, and that told me some names that are on various teams. So I know, for example, that Tyler, who is a student at CUAA, plays hockey. Awesome. So this is an element of the relation. All right, what else? Let's see here. Matt is on the basketball team. Excellent. So that's in the relation. A person in that set is related to the team that they play on. Excellent. And let's see here. There's a Mackenzie. And Mackenzie also plays basketball. So maybe I should have specified women's team versus men's team. And then there's also an Emily that plays volleyball. So in a relation, we just get that the elements are related to one another. Tyler is related to hockey because Tyler plays hockey. Matt is related to basketball because Matt plays basketball. Mackenzie is related to basketball because Mackenzie plays basketball. Emily is related to volleyball because Emily plays volleyball. It's very straightforward, very simple. So this relation is defined by some rule which is described here. Okay, these two elements are related if and only if this condition is satisfied. Here in the first example, we just plucked out some elements from the collection of ordered pairs, okay, and gave that as our relation. So a relation again is just the just a subset of the cross product A cross B, or A cross A, right? Binary relation from A to B is a subset of this. Relation on A is a subset of that. The word binary, we don't really need to know. It's just kind of added in there. The emphasis is that we're looking at two things. An element from A and an element from B is essentially what's going on there. Binary, two. All right, that's all that I wanted to share for now. So we'll continue taking a look at relations, in particular equivalence relations, in our next video. So I'll see you guys back in the workshop very shortly.